Now, explain how the Young's experiment gives support to the argue that wave-like nature. So this experiment is double slit experiment they're talking about, not the single slit experiment, right? So this double slit experiment, how can we use the double slit experiment to explain, this particular experiment? Through this experiment, Young was managed to prove very 100%, convince the people, right? This experiment results would help the waveform of energy. Energy, light. Light is transmitting in a waveform, not like straight line. Yeah, it is going like a wave, like that. Rather going straight, not going straight, just going a wave, right? So this experiment prove that. So if it is proving, what part of the experiment you taking to prove it? Yeah.
Yeah.
Yeah. What are you going to tell now?
So when I talk about like the diffraction and how
So just imagine, yeah, we learned few different aspects of this experiment, right? We saw bright zone, we saw dark zones, and with the slit actually, and then overlapping things and all various things. So yeah, so what is the most suitable part to explain? This is happened because of the waveform. If this is not a waveform, this is not happen. Yeah. What is that?
oh, sorry.
So kind of like the whole experiment we discussed today, and if for somebody you can tell that, oh, this experiment proved that light transmitting like a waveform, right? Transmitting in a waveform. So this part of the experiment, this particular part of the experiment would explain you, this particular part you don't see this part, right? If it is not waveform, so which part you pick from the whole thing? You have idea? So I'm not pressurizing, but I just see whether I just let you to think about it a bit, right?
Okay.
So yeah, you have anything? Don't be shy. Just put it out. All right, don't worry, right? Don't worry. So
Yeah, I'm not really
okay,
sure.
yeah, if you don't have, yeah, so all right, it's all right. First time you're hearing that, I know that, right? So it's not a weakness. It's not a weakness at all, right? So what I'm telling is, so what they're telling is in the book. So we can pick the light zone and dark zone. That is very same thing, right? So the overlapping waves make the wave higher, right? For example, now you take a string like this, right? And it clamps to the wall. Clamps to the wall. It's a wire, right? It's a metal wire. and you make a kind of a wave and push it that side, and it's actually spreading. And you can do the same thing, but by just putting like a stimulation here. I actually go to both directions. Go to this way and that way. Agree? So now you can make another one. I take a different color. Make another one from here. So then, so another stimulation start from here and going there. Now the places like this, you can observe when they are overlapping like this, the behavior of the string not moving, right? If the places, right? If the places
Monday, Tuesday, Wednesday.
going like that, right? Actually, the string actually make this kind of motion. See? So it is same thing happen on the waves on the water, right? Waves on the water, same thing happen. So one source make waves, right? And another source make waves as well. So if you look at the surface, the object on the surface going up and down, and right along the track you keep objects like that, right? So they are actually, yeah, the difference in the water waves and the other form of waves, right? The sound waves, water waves are different from other radiomagnetic waves. I tell you that, right? The radiomagnetic waves, such as light waves, right, and X-rays, and you can take the laser beams, or you can take the white, all the seven wavelengths in the white sunlight. So they all are electromagnetic waves, right? And the heat waves as well. So they are electromagnetic waves. So they come from sun to the earth, right? They can come from sun to the earth. So in between the universe, are there anything in the universe? Oh, well, you can have one or two molecules or small particles with a quite distance, though, very quite a distance. But in general, most of the area on the space it is a vacuum. Quite amazing, but it is true. It's a vacuum, right? There's nothing. So, but these electromagnetic waves can come through a vacuum, right? If you create a vacuum in between two glasses, right? So all these kind of electromagnetic waves, right? Just imagine two glass plates. So make a seal container. You generate these waves here. These generate waves, change the shape. Even the light waves come from sun to the earth, come pretty straight, wavelength getting so extended, right? Because more the lesser the dense, right? The wavelength getting higher because they have no resistance. They can go straight away. Wavelengths are there, but they're almost like a straight lines, right? Because such a big wavelength cannot observe until they come to the surface of the earth, surface of the atmosphere. Atmosphere is quite dense though. Atmosphere, they start to form the visual wavelength, right? And if it is entering into a even dense medium, like such as a glass, let them to go through, right? We know the glass let the solar radiation or seven different wavelengths of the solar radiation can go through the glass. But the difference is when they entering into a solid medium such as glass, so the wavelength make different. Wavelength getting smaller, so they have to push harder. That's why the wavelength getting smaller, and they make their energy maximum, right? So a small wavelength has a bigger, higher energy. So yeah, everywhere, smaller the wavelength, you have higher energy, higher penetration power. So, but if you make a sound waves, speaker, loudspeaker, so speaker is yelling, making a big sound. Can you hear it from other side of the vacuole?
I don't think so.
Yeah, you can't, because even the water waves like that. So they don't actually transmit in a waveform. They do transmit in a waveform, but not the particle. Particles actually moving quite a short distance. So, for example, in actually sound waves, particles moving small distance like that, right? Small distance like that, and not going any more beyond that. All right. So, however, even this the water waves, these particles going up and down, right? Up and down. Only thing is, if there's a constructive interference, these particles moving quite high, right? Quite high up and quite low down. They both, right? Well, actually quite high. I would say quite high, right? And the low flat and high, and in between these two, right? So this is constructive interference, but particles not really moving. That is why, that is the difference between a sound wave and water wave with radiomagnetic wave. Radiomagnetic wave, the particles moving with the energy. They carry energy and they're moving. So here, the energy moving, right? But particles does not moving. So yeah, so the vibration only the moving. Yeah. So remember the tsunami.